Okay, welcome to an episode of Flying High with Flutter. I'm your host, allenwyma. Today I'm with Boris Batteux, if that's how you say it properly.
Yeah.
He is a security researcher at Guardsquare, which is it's a software consultancy based out of France. Is that right?
No, so actually we are a company, the main company is based in Belgium, in Leuven. And we are developing a solution for mobile app security. So we provide protection, and we also allow to monitor threats, and also some app testing about security.
Okay. We recently ran into your article about how to reverse engineer Flutter apps, and there's a lot of people who are interested in this. Like, why did you even get started taking a look at this?
So there is several things. So first, as a company, we noticed that many of our customers are moving to using Flutter instead of Java or native programming. And so for us, it was interesting to see how best we can protect the app using the new technology that Flutter is. And so as a company, we developed a lot of things to protect basically Flutter app. And so this is another team we did that. And on my team, so on the security research team, we are doing several things. And one of these things is investigating threats, so the actual threat and the one that can come in the future. And so we wanted to look at Flutter and say, okay, is it more secure, less secure than any other language? Can it be reverse engineer easily or not? And we wanted to check that. So, and because for reverse engineering part, the state of the art on Flutter, so there was a couple of blog posts released, I guess, by André Lipke in, I think now it's 2 years ago, something like that. And he did a very in-depth analysis of what is Flutter and how it translates to the compile file, so the Dart snapshot. And he analyzed that, and he explained how to parse it and things like that. And then he also show how to understand how Dart assembly code look like. And so basically his conclusion was that it is possible to recover secrets that are stored in a Flutter app, but it's very, very hard. And so, again, it was 2 years ago. So we wanted to know, is it still true? Or is it because of something else? And when we discuss internally in the team, we say, okay, maybe the fact that it seems like it's hard to reverse engineer Flutter is because there is no good tool to reverse engineering that. And we decided to try to see how much time it would take to create some tool that will help reverse engineer and understand Flutter application. So this is basically how this work started.
I'd like to kind of take a little bit small step back, right? As a typical Flutter developer, I mean, should I really be worried if somebody can reverse engineer my app? Is there something that I need to be aware of? Is this something that's a problem at all?
So you do reverse engineering for multiple reasons. So the first classical one is to understand how an app is working. So let's say you develop one super sensitive algorithm. Basically your code need to be protected because you spend a lot of R&D time to develop it, and you don't want your competitor to steal it. Then you need to protect it so that other people cannot extract it from your app and reuse it, basically. The other thing that you should protect is, for instance, if you store some cryptographic key or some API key inside your app, maybe you don't want them to be known by anybody. So you don't want me, for instance, to take the app from the store and recover all your secrets. So if you have this kind of problematic, you need to protect your app so that it's harder to do. The other thing that we saw in the past year, because we work a lot also with a gaming customer, and attackers try to develop cheats for game. So if you are developing a game in Flutter or any other language for that matter, you will want to protect again the development of cheats. You want to detect cheater, and you want to basically to prevent cheating on your game. For that, you need to protect your app.
Okay, so basically, like you said, if somebody can get a hold of my app, they can actually see any kind of proprietary um, algorithms and actually see how they work, right? We can actually translate those back to physical or to actual dark code.
Yes, so reverse engineering is a kind of a complex process, and so there is something in Flutter that makes it that even harder, but doable, like we will maybe discuss later. But yeah, basically you take, when you compile an app in Flutter, so in release mode, we are not speaking about debug mode here because when you publish to the store, generally it's in release mode. So the code is compiled to native language. So it's in a library, native library file, which is called libapp.so. And inside that, it's what we call the Dart snapshot. So the Dart snapshot is a big piece of information. You have all the strings that you are using inside your binary and other things that we can discuss later on. And you also have the compiled code of your compiled Dart code. So it doesn't look like Dart code at this stage. It's assembly instruction, like ARM instruction or X Intel instruction. And so when we reverse engineering a software, we take that, we use all the information that is inside this file to get to decompile code. So basically, we will not directly go to Dart code. We will get to something which is closer to C code because we decompile from native code to something, and this is closer to C code. So if you have no protection at all, so when you build your Flutter app, one thing that we noticed is that there is a lot of what we call metadata, which is stored inside the Dart snapshot. So the metadata that are useful for a reverse engineer is, for instance, the name of all your class and your function. So basically, if we know where to look for, we can have all the name and the name of the function and the class very easily. And because most of the time dev do proper development and the name are very verbose, I mean, if I read the function name, I can understand what the function is doing most of the time if it's well developed. So it gives me a lot of information on what is actually going on.
Now, the other thing I think people should be worried about too, like you said, that there's a way that you can kind of decompile like secrets, right? So some people, they will like, maybe how do I say this? When you use like Firebase and things like that, you do end up having to have those configuration files, right? So there actually is ways that people can pull out your secrets and things like that, right?
Yeah, exactly. So yeah, this is a good example of something sensitive that can be extracted from your app. And so the thing is that we know, and most of people know that it's possible for Java or any regular develop Android app, but it's actually exactly the same for Flutter. And this is something that's maybe some people thought it was harder because of the fact that it's compiled to native code. So it's not as high level as Java or something like that. But in fact, it's the same as reversing native code, and it can be done.
Now, I'm kind of curious too. Like, have you guys taken a look at? I mean, Firebase is probably the most important or most popular kind of package and things like that. Like with the way Firebase currently works right now, is it actually possible to reverse like your configuration files and things like that that are actually made for Firebase right now? Have you taken a look at that?
I didn't took a look to that. Maybe this is interesting, and maybe we should at one point do that. But I don't see why it won't be possible, to be honest. And the fact that, again, Firebase, it's something that is I mean, it's a library and things like that. So it's used by a lot of people. So it's the fact that many people are using it has also an impact on reverse engineer, because if I spend, let's say, 1 month reverse engineering this, I can use that for all applications in the world that are using Firebase. So the impact for me, the benefits as a reverse engineer is very huge because everyone is using that. So again, I guess it can be done, and it will be definitely worth it to do it.
Yeah, it just kind of popped up in my mind because it's like the biggest package and the way configuration works. Um, Now, is there, because actually this topic is quite interesting to me because, Yeah, I mean, a lot of people will like use like environment variables and things like that to stick configuration stuff in there, especially like secrets and things like that. Is there actually a safe way to protect yourself against people doing this? Because I've heard of one way is like you need to at runtime pull this stuff from a server. Is that like the only way that really I can be safe, or is there any other way that I can do this?
Yeah, so definitely, if you want to do something that is very secure, you need to have to get some information from your backend at one point. Because if you are doing everything on the client side, it's an architectural weakness, and so yeah, you need at one point to have a backend that sends you some information and that make it more secure. But nevertheless, if you are doing things on the client side, generally you will have at one point to have some secret store on the client side. You can, for instance, use Android key store. So it's a hardware-backed piece of so it's in the TE, for instance, so in the trusted execution environment of the ARM chip, and so it allows to store key there and to use it. And when key are inside of this TE, an attacker cannot extract them easily. It's very hard. It's hardware attack and stuff like that. So yeah, you can consider that you are safe enough by doing that. And there is the same thing on iOS for keychain, for instance. But the thing is that you need to protect the way that you are calling this library, because an attacker can basically call the key store, use the key store, the key that it's stored inside the key store instead without using your app. So there is some risk, but yeah, you need to protect this basically. You cannot just use the API, you need to protect it.
I'm just kind of curious. Maybe this is a side question. As you can see, my questions aren't really in order necessarily. They kind of come to me as we're talking. Like, what is like one of the biggest security problems that you usually run into, like most common?
So yeah, basically, so the most common in apps that don't think they need security is keys or secrets stored in plain text inside the code. So basically, you have your class, and there is one secret that is one member of your class, and people store that, saying that okay, it will be compiled, it will be safe, nobody will get this secret. But this is plainly false, and it's very easy to get. So this is really the most common weakness that app have. So, and this is really entry level attacker. I mean, you don't have to be very skilled to recover this kind of secret. So after that, there is many other threats that we see often, but are far more evolved. It's, for instance, when people try to develop, when I speak about game, when they try to develop game cheats, they will use some kind of tool which allow them to inject some code inside your application. So this is called either hooking or thing like that. Or we will patch. They can also patch your application to basically, let's say you have a perfect code logic. Everything is nice and perfect, super secure. And there is a if condition that check whatever you want. And they can just patch this if condition to make it, to bypass your check. So even if your code design is 100% secure, there is still a way to change your code logic. And so this is more advanced attack, but we see that a lot. So yeah, but this is dynamic attack, and it applies to basically all apps.
Now, is this something that like basically every developer should worry about, or is this just like certain developers, like maybe people who create banking applications, etc.?
So yeah, for instance, for banking apps, it's mandatory for them to care about that, because if you want to be able to publish your banking app and with some feature, you need to have a certification of security certificate. So basically you pay some laboratory that will inspect your app and check that everything is doing well. So for them, it's mandatory. They don't have the choice. And for most of the other app, if you have something to protect, yes, you should care about that. If your app is just front end and everything is done on the back end, and you just see basically your website or whatever, maybe you don't need that. But even in this case, if you, let's say, on your app, you ask user to enter their credential, a possible attack, not one that is used often, is to basically log everything that is entered on the keyboard. So it can be used to get user credential, user password, or something like that. So if you handle some sensitive user data, you should also care about that. And if you have some, let's say, money, if you have some business logic, let's say, for instance, you have two versions of your app, one which is free and one with ads, and one which is paid. And so you need to be careful that it's not easy to remove the ad from the free version or to get the paid version for free. This is also some kind of attack. So yeah, it depends basically on your. You need to think about what can happen to my app, what is the worst thing that can happen to my app, and if there is no protection, and if there is money to gain for the attacker, it will happen at one point.
We do have a question from the audience. They're asking if you have a demo for them about how reverse engineering works. I don't think you prepared a demo, right?
No,
so
I don't.
Then maybe check out your article for kind of an in-depth.
Yes, but I mean, yeah, I can share a database at one point if you want to see how it looks like. I can do that if you want.
Actually, I'd like to kind of go a little bit back more into your past, right? Before we started the show, you did say you're not a developer. Is that correct?
Yes. So yeah, I started as a cryptographic engineer working so with very low level programming stuff. So it was mostly C and assembly language directly. And yeah, it was super fun for me because I learned how to do some programming, but by having a strong focus on how I use the memory and stuff like that. So it was kind of interesting. But then, yeah, I was working next to a team of malware reverse engineer. So people who were reverse engineering malware. And yeah, it seems so fun to me. So I beg them for work and they give me some sample and I reverse engineer them. And I really love that. And I decided to switch full time to reverse engineering and penetration testing on mobile app. So
You said on a mobile app.
yeah, so I'm mostly focused on mobile applications, so Android, iOS. When I started reverse engineering, actually it was on Windows because for malware it was the main target at this stage. But yeah, I choose to work on Android at the start.
Now it's mostly Android, right? Or is there any iOS?
I started working on Android, and I'm let's say a bit more specialized on Android, but I also do some iOS. And in the team, we have a lot of people working on iOS.
Now I'm kind of curious. Like, is iOS actually more secure than Android? Because I feel like they always push that.
Yeah, we cannot say that there is a more secure OS than the others. They both have their advantage and their issue. But yeah, regarding security, it's kind of the same thing. The thing with Android is that it's an open platform and you can do basically whatever you want on your device. So on Android, if you decide to take your device, modify the ROM of your device and reinstall it on the device, you can do that. And if you are doing that on Android, you can basically break all the security of the device. So this is why maybe sometimes people think it's less secure. On iOS, you cannot do that. You cannot change the ROM. It's Apple who signed it, and it's just the thing that Apple want to be on the device that it's on your device. But after that, people found so 0-day or thing like that, which allow them to become root or to jailbreak the system on iOS. And the complexity level of that are generally the same. If you look at for that, there is some bounty. So when you break the system, you gain some money, basically, a lot of money. And the price are almost the same between Android and iOS. Sometimes it's iOS which pay more, and sometimes it's Android. So.
Now, should I have any kind of concern that like people may like take my app, modify it to do some crazy stuff, and then re-release it? Because we've seen this attack happen quite a lot recently. You know?
Yeah. So yes, this is a perfectly valuable threat scenario. So people do that either for IP stealing, so rebranding your app basically, so stealing your work and creating basically reuse what you have done and publish it and gain money. or to change the behavior, like for instance on game, if you want to cheat the game, patching is a good way to go. So you change the behavior, and then you can distribute that wherever you want. Either on legit store, it's generally they get removed after some time, but on custom store, they can stay for a long time. So yeah, you should definitely. I mean, if there is money inside your app, I mean, you gain money or something like that, yeah, you should care about that.
Now, is there any like legitimate uses for reverse engineering a Flutter app?
Yes. So yeah, I spoke, for instance, at the beginning about malware analysis. So reverse engineering it's a tool basically that can be used for good and bad. And if you want to check that Flutter application or any application basically is malicious, you will have to reverse engineering it. So this is a perfectly legitimate use case for reverse engineering Flutter app. The other thing that we can think of is, for instance, if you want, let's say you publish a voting app written in Flutter. It's for citizen or citizen, it will be important to check that there is no vulnerability in your app. So yeah, sure, it can be done with open source program or going through a lab, but people can also try to reverse engineer the thing to see if there is no backdoor or something like that. So there is potential vulnerability search or voluntary vulnerability introduced in the app that can be found out by reverse engineering the app.
For one thing, I've seen quite a lot of in my experience. So I'm a consultant, and what I've seen a lot of people actually do, or what I think would be useful for them, is like they usually bring on these other consultants or former employees that like left, and when they leave the company, they take some code with them, and like they have an app that's in the wild, but then they don't have all the code. So I can imagine that reverse engineering the app to get the actual source code back could be useful for them.
Yeah, it could for them, yes. Yeah.
Now, with Flutter becoming more and more popular, you say it's becoming a bigger and bigger target now.
Yeah, we have more and more people asking us, are we supporting Flutter? What protection are we provided for Flutter and things like that? So yeah, it's important to develop some things about that. And because of the specificity of the language, the fact that it's compiled and things like that, the snapshot, there is we need to do some special thing to support that. And we did that in the past. I mean, not me, the team. We have a big team working on that, very smart people, and they did that several years ago already, and they support all versions. I mean, a lot of Flutter versions.
For people who are kind of interested in this topic at home, right? Like, how did you kind of really get into it? Like, what are like some steps that we can get into that we can also learn the basics of reverse engineering ourselves?
So currently there is a lot of books that have been released in the past few years about reverse engineering. So there is, personally, I was interested in malware analysis, so I started with a book called Practical Malware Analysis, and I still see it's one of the best reverse engineering books. So and it's written like a course. So a course. So you start and it gives you some easy task to do at the beginning and gives you the solution and things like that. It told you what tool you should install and so on. And it's a step-by-step process that explains you lots of the how reverse engineering can be done. So this book is really awesome. And after that, now we have the chance that there is a lot of what is called capture the flag, so CTF platform, which gives you a lot of challenge. So basically, it's like small puzzle or small try to break the software. For instance, try to bypass the license check of this small program. And so there is plenty of sites who do that. I use, for instance, RootMe, which has a lot of challenge like that. And the good thing is that you start with very very basic stuff that are can be done by anybody that want to learn that, and you end up with very very complex challenge that even senior people can spend some day trying to solve. So you really have a big margin of progression just doing that, and it's free for most of them. So Yeah. You just need time and practice.
Now, because you've already worked with Android, you've worked with iOS a bit. Now, when you're working with Dart, like I read everything, but it's been a few days since I took a look at it. There is some complications that Dart brings, right? Because they have like their own registry system for like the memory. So, like, how do you? I mean, I'm just trying to figure out like when you compare like doing iOS and Android and then going over to Dart, is it like a big problem to have this kind of thing, or is it just a slight annoyance? All the different differences that it brings.
So when we start, I think it was a strong annoyance because, like I said at the beginning of the podcast, the thing is that there was no tool or very limited tool or tools that support only all Flutter version and things like that. So there was no tool where we can start, and so it was nearly a big step to reverse Dart code compared to other language, because the other language have tools that are available for a long time. So yeah, it was hard at the beginning. But then there is two things that can help motivated people to start reverse engineering Flutter app. Is the fact that first and foremost, the full SDK is open source. I mean, you can go on Flutter and you have all the Flutter code. So basically, there is nothing that is hidden from you. Even the snapshot parsing, for instance, it's something super complex. I mean, for me at least. But you have the code, so you have everything you need to parse it and to understand how they are doing that, why they are doing that, because there is comment in the code and everything like that. So it's a big help, and it can help develop tool to parse the snapshot or do whatever you want. And actually, there is one super cool tool that been released, I think, last year, which is called fhwf. And basically, what they did, they changed some file inside the Flutter runtime. So they started by changing the socket.cc file, so the thing that handle all communication with your backend, and they changed that to add logging. So basically, they log all your communication with the backend, and then they recompile that and they inject this new modifier libflutter.so inside your app, and then it leaks all your communication with the backend. And so they do that. They use the fact that really it was open source and they can recompile that. And yes, so now there is this kind of tool, and I use that actually in the two blog posts that I wrote, because they added this year one feature which allowed to dump all a class and function name. So basically, I don't have to do a Dart snapshot parser, which is not hard but time consuming. I can just use this tool, and it will work on all Flutter versions, because basically they just recompile Flutter with some logging information. So it's easy to handle the new release of Flutter, and you get a lot of information. So this was the first thing that we did, and which helped us a lot. And this is new. It's from this year, so this is also why it's not very well known. And after that, there is some specificity which are, because basically you are running your code is executed by the Dart VM, so there is a lot of complexity there. There is one indirection between all the objects that you are using and the code that is referencing them. So when you start looking at reverse engineering Flutter code, it's like basically you have a file, so with a big mapping, which an ID, so 1, 2, 3, 4, 5, 6, and a string in like so a dictionary basically. And it's like in your code, you are always referring to this dictionary instead of seeing the string directly. So it makes the code, so the decompiled code way less readable and harder to reverse engineer. But then again, all the information to solve that is needed by the Dart runtime. You need to have that to make your program work. So what I did is that I managed to find a way to get this information from memory and to inject that into the compiled code. And what we notice is that it's actually not that hard. It can be done with moderated I spent several weeks, but it's not months or whatever. So yeah, it can be done easily, and when you have that, you resolve some of the specificity of Flutter. The two other small specificity of Flutter that we saw, but have way less impact on reverse engineering, is the fact that Flutter use a custom stack, so they are not using the system stack. So you have discrepancy between the two stack, and because the reverse engineering tool assumes some stuff about the system stack, the decompiled code look weird a bit, but we can fix that easily. And the final stuff, the final thing is the custom calling convention. So basically, when you are on ARM, the arguments are passed on a by register. So in X0, X1, X2, and so on. And on Flutter, it's all pushed on stack, on the custom Dart stack. So yeah, we need to handle that, but we managed to do that in the blog post, the second one.
Now, when you have a Dart application that's actually compiled natively, there is some pieces that are also brought in too, right? I think like the garbage collector, things like that, are not actually kind of native per se. Do those cause any kind of problems when you're trying to reverse engineer things, or no?
No, we see that as call. So, I mean, we see that there is a call made to the garbage collector or something like that. And for us, so when you start reverse engineering, you can be annoyed by all this kind of stuff, because this is additional information that you don't care about. It's just to make your program work, but there is no functional value in reverse engineering that. So when you start reverse engineering, yes, it can be hard, but after a while, you know how to ignore that. It's like when you are reverse engineering, for instance, Objective-C, the code, there is a lot of metadata and a lot of function call that are done before doing the actual interesting stuff. And so you learn to only reverse engineer the interesting part, and you totally ignore all the language specific function call.
Now, based on the popularity of Flutter happening more and more, I mean, you said like right now there's basically no good tools, but there's starting to be, right? And do you think that there's going to be more and more tools available?
Yes. So basically, the people who develop reverse engineering tools, they work also on the same principle. If a technology is used a lot, then it's worth investing in it and developing some tool to reverse engineering and all. And yeah, in the blog post we show, so it's obviously it's a proof of concept. I'm not saying that I have a perfect tool that will work on all apps. This is not a goal. We don't want to give some tool to reverse engineer Flutter, but we want to show that it's possible. So yeah, but if there is many people going to Flutter, many reverse engineers will want to reverse engineer Flutter, so this tool will need to support this. And yeah, we saw some already. There is one tool called Jeb, which already had some basic Flutter support in I think 2 months ago, something like that. So the next tool are likely to follow, and to have that. After some time, it always happens.
Well, I'm also thinking about something too, right? So not only is Flutter like native code necessarily, it also can work on web too, right? I mean, is this also a concern? Because I mean, when you have web, basically you have everything, you know?
So yeah, I'm gonna be honest. I didn't check that at all. So yeah, I cannot say. The work that I did was mostly on a released app, a mobile app, and on that for me it was always compiled code. But yeah.
Yeah, because I can imagine like if you have this app that works on iOS and Android, I can only imagine that it'd be easier to take apart the web rather than take apart the iOS Android version if they're basically using the same code.
Yeah. So, in theory, I do agree with you. I didn't check that.
Now, do you have some tips for people as a developer? Like, what should I do? Like, what are like some basic things I can do right now to help kind of protect myself? I know you mentioned something like this word's so hard for me, even as an English speaker. Obfuscation, is that right?
Sorry.
Obfuscation, where you like make the code more complex.
Yeah, obfuscation. So yeah. So you can apply obfuscation. So obfuscation is a technology which basically will make your code way harder to understand for reverse engineer. So just to be clear, because there is a Flutter obfuscate option inside Flutter. So inside you can Flutter build -- obfuscate, I guess. This is not really obfuscation; it's name obfuscation, which is a subpart of obfuscation. And we show in the first blog post that there is some big limitation of using that. So you should definitely use it, but it's not enough. So yeah, in code obfuscation, what you will do, you will change the code logic in the assembly level, and so it will make it way harder to reverse engineer. So this is the first thing that you should do if you have anything to protect. Then you need to ask yourself, is it an issue if someone is modifying the behavior of map at runtime or spying of my communication with the backend or something like that? If you have this kind of problematic, you will probably need to check if you can add some protection against threats. So there is it's called RAS, runtime analysis self-protection. So basically, it's tools that allow to detect attacker at runtime and to crash your app or do whatever you want. So you can use that if you want to protect against patching, hooking, or running on a rooted device, something like that. So it's the things that you can do during the development stage. And I think one of the important things too is to also test your security. So security tests can seem very frightening, and going to a pen test lab and things like that, it can cost some money. I believe it can be useful, especially if you have a big security concern and you need to check that. So you can go to manual penetration test. It will cost you a bit, but it's really helpful, and you will really have a manual analysis of your app. And the good thing is that there is also free tool that allow to run check automatically on your app. So you can use this kind of tool to verify that you don't have any big architectural weakness in your app, or that your app is protected as you want. So you can specify what you want to check and things like that. So this is also something that you should consider, or at least you can try it. I mean, and decide if you want to integrate that in your CI or whatever. But the main point here is that you need to test your security somehow, like you are doing for regular testing, functional testing.
Now, I do have one quick question. Maybe this is mostly for me. Most developers are using like Firebase, but for me, I like to use an actual kind of backend. What I hear is probably the most kind of secure like login stuff is probably using something like OAuth 2 with like Pixie. Is that still kind of the main way to log in?
I don't know. I would have to check. I think it's good, but yeah, I would have to check.
Yeah, what do you mostly look at yourself? You're just mostly kind of looking at the application itself, making sure that like you said, people cannot patch certain things in certain ways and do crazy stuff, right?
Yeah, exactly. Yeah. That, and also trying to extract secret, or for instance, yeah, but yeah, we are working on the protection side. Currently, I'm working at Guardsquare on the protection side, so it's mostly checking that yes, the app are well protected as we expect. So.
Just kind of curious, like, what is like one of the most craziest things you've seen out in the wild in terms of like people doing stuff to people's applications?
Well, you can do anything you want. We've seen some cheat on game who can, add money, or basically anything you can think of. To change the game speed, or doing some aim assist. So basically, helping you to play better or something like that. Yeah, this is this kind of stuff, I guess.
I don't think I have any other questions. Is there anything that you wanted people to know about or anything like that before we start to sign off?
No, I think I speak about what I wanted to speak about.
If people want to follow like what you're up to or like current status of Dart, what do you call that? Reverse engineering, things like that. How can they follow up on this or follow up on you?
So you can follow on Twitter, or otherwise, I think on the Guardsquare GitHub also there is some. I've created a repo for the tool that basically if you want to try to reproduce what I've done in the blog post, there is a repo on GitHub with all the tool and things like that, and the scripts. So you can use that, and yeah, you can also follow. I think normally I should release another blog post on the dynamic side of attack on flutterappp soonish. So basically, showing how we can develop some small hack.
How many more articles will there be in the series?
I think one. Just the dynamic part to basically to answer your last question, what are the crazy things that we can do with once we are reverse engineer the code, what can we do with that?
We do have a last minute question. Somebody asks, is denying access to a rooted device a solution for your app?
So it depends. On some case, it can help. For instance, on banking application, you don't want generally you don't want to have people that can run your app on rooted device. So yes, it can help. But depending on your business logic, sometimes you want to allow a rooted device. I know that some gaming customers don't want to crash on a rooted device. So it depends. It depends basically on what are your security needs. And so, yeah, in the generic sense, yes, you should not allow to run on rooted device, but if there is no risk, why not? The most important thing, I guess, is you want to be sure that your app is not modified. Because so you can run on a rooted device as limited impact, depending on your security need again. But once you allow an attacker to modify your app, so either using patching or a technique which is called hooking, then you can do anything you want. And this is generally bad. So this, I think, having some kind of hooking or patching protection is really something that is really important.
Okay. And with that, I thank you for your time and looking forward to the next blog article. This is some interesting stuff.
Thank you.